So following on with non-right angled trigonometry from my previous video on area of a non-right angled triangle, we have two other rules that we use with non-right angled triangles, and it's to find unknown sides and angles. Now normally in normal right angled trig we can just use sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. However, those rules only work for right angled triangles. So we need two new rules, which is the sine rule and the cosine rule. And both of these work for non-right angled triangles, and which one you choose or which one you use depends on what information you're given. Just like with right angled trigonometry. If you're given certain sides, you use a certain ratio, and it's the same with this one. So there's two different variations of each of the rules. The first one, which is the rule that we use to find the sides, is always on a formula sheet. However, the angle formula isn't, because you should be able to manipulate a formula. However, I strongly suggest popping them on your notes pages for exams anyway, the angle formula, because why waste time in an exam manipulating a formula when you could just pop it on your notes page? So, sine rule. Now, the important thing with sine rule is that you only ever use two of these things. So, yes, it's got A on sine A equals B on sine B equals C on sine C. However, you only ever need two, but it can be any of the combinations. The only important thing is that it is side A over sine of angle A. So you've got to remember that the opposite side goes with the opposite angle. And if you do that, then that's fine. You should get the right answer. The other thing that I always suggest, because fractions are involved, we always want the unknown on the top and on the left. So what I mean by that is if it is side B that we're finding, we need to have B over sine B equals A on sine A, for example. So that B, that is the unknown that we're trying to find, needs to be on the top and on the left, and you'll see that in the examples that follow. So we've got the two different formulas. All it is, the angles one is just the reciprocal. We've just flipped them all upside down, and that is to be able to keep the unknown on the top and on the left. So first example, we have, like I always suggest, you label your sides first. So the vertices are labelled. I'm just going to label these sides just so we can see them. And you can see that angle C is blank and side C is blank. So that means we immediately are going to eliminate C on sine C because we don't use it, it's useless. The other two, however, we are going to use A on sine A, and I'm going to put it on this side because the X is on side A, which is, and then we've got B on sine B. Once we've done that, we can just substitute in what we know. So little a is X over sine of A, which is 33, is equal to B, which is 15, over sine of 112. Now that we've got that, we can rearrange. So all we do to do that is we're moving this to the other side. It's currently division, so it becomes multiply. So we would have 15 sine 33 divided by sine of 112. And again, important that your calculators are in degrees for this. And to one decimal place, once you pop that into your calculator, you should get 8.8 centimetres. I have seen some of my students in the past who like to get two different colours when they're first learning how to do sine rule, and they just do this to circle and show them which side goes with which angle, but you don't have to do that. It's just an option there for you. I'm just going to get rid of those so you can see the triangle again. Second example. So first thing, this one's not labelled. So the first step I'm going to do is label my corners and then my sides. Now, we're trying to find little c. So straight away we know that we're going to do c over sine c on the left because we want the x on the top and on the left. We've got a bit of a problem here though because we need either side b and sine of b, or we need little a and sine of a. Problem is, we don't have little a. We have angle A, but we don't have little a, so we can't use that. But because we've been given 40 degrees and 46 degrees, and we know that in a triangle there is 180 degrees, we can actually work out what angle B is before we start. So I'm just going to do that down the bottom here. So angle B is equal to 180, take away 40, take away 46, which leaves us with 94 degrees for angle B. So now I can go ahead and write B over sine of B, because that's the one we're going to use. You can also add 94 degrees to your diagram if you like. Then again, we just go in and we substitute in what we know. X on sine 46 is equal to 20 on sine of 94. And then again, we're just moving that sine 46 to the other side, so we get a times. So we do x is equal to 20 sine 46 over sine of 94. And again, you just type that into your calculator. And to one decimal place, you should get 14.4 centimetres for that side. The next example is looking at finding an angle. Now, you'll notice that I've written in here, the angle is acute. It is normal for sine rule questions to state this, or it might say angle is obtuse, or there will be enough information within the diagram to know whether or not it is the acute angle or whether it's the obtuse angle. Now, the reason this is a problem with sine rule is because sine of A and sine of 180 take away A are exactly the same value. So what I mean by that is sine of 30 is 0.5 and sine of 180 take 30, which is sine of 150, is also 0.5. So we run into a bit of a problem there because your calculators, as scientific calculators, they can only show one answer and they only show the acute angle. So if the diagram or the statement suggests that the angle is obtuse, once you've got your answer, you then have to do 180 take away that answer to work out what the actual answer is. When you do this during apps, you can put certain conditions into your calculator, into the Casio calculators, that allow you to only get the one obtuse angle. But for now, with using scientific calculators, you just need to do the 180, take the acute angle if it is obtuse. So for this one, we're trying to find angle B. So to do this, we're going to have sine of B on the top because we want it on the top and on the left. So it's sine of B over B is equal to sine of A on A, because for this one you can see there's no information on C and no angle here either. So then we put in what we know. Sine of B on 20 is equal to sine of 60 on 18. Then we just do like we did before. We move the 20 to the other side and it becomes times. So we've got sine of B is equal to 20 sine 60 on 18. And then, of course, because just like normal, we need to do the inverse of sine. And again, you can work that out if you want to, but I always suggest for sine rule and area that you just type it in like so. And then you pop that into your calculator and you should get an answer of 74.2 degrees to 1 decimal place. Again, unless it's stated in the question, rounding to 1 decimal place or the nearest degree is fine. So moving on to cosine rule. Cosine rule, again, it has two different formulas. The side formula is there, c squared is equal to a squared plus b squared. Take 2ab cosine of c. Sounds super complicated, but it isn't really. The important thing with cosine rule is that whatever the side you're finding, so if you're finding c, then the angle that you're using, this angle here that you're using, is capital C. So, for example, if I was finding little a, I would be using capital A for the angle, and the other two sides would be used in place of A and B in this formula. And again, you've got the angle formula there that I suggest putting on a notes page because it saves you from having to rearrange in the exam. So, first example, we're trying to find x. So I've actually used different letters for this one, and it's to show you that you need to be able to adapt the formula from C, A and B to any letters. So I've got x is the unknown, so we're going to put here x squared is equal to, then it's the other two sides. So it was a squared plus b squared. In this case, it's going to be z squared plus y squared. And then it will be take 2zy cosine of capital X. And then the same as before, we just fill in what we know. We've got x squared is equal to 8 squared plus 10 squared. Take 2 lots of 8 times 10 times cosine of 79. Now you'll notice here I've just used brackets instead of doing multiplication signs. It's just much neater. You can do time signs if you want to, but much neater to put it in this way. Again, just type it into your calculator with your calculator in degrees. And that comes out to 133.4706 to 4 decimal places. Again, try not to round too much before the end. Now, it's just like Pythagoras with this. This was x squared. So to find x, we actually need to do the square root of that answer. So we just pop that in and we find the square root, which gives us 11.6 to 1 decimal place there. Second example is using the sides to find an angle. So we're trying to find angle Z. So we're going to have cosine of Z is equal to x squared plus y squared take z squared over 2xy. Then we fill in what we know. So we've got cosine of Z is equal to 20 squared plus 22 squared take 17 squared divided by 2 lots of 20 times 22. Now, for cosine, I would suggest actually working out what that right-hand side of the equation equals, especially on a scientific calculator. Once you've got your Casios, fine, because you can pop them in as fractions, and then the calculator understands to work out the numerator and then do the denominator. But if you don't have that capability on your calculator, it's easier if you just work out what that equals. And then, same as before, we have to do the inverse of it, which then works out to be 47.5 degrees to 1 decimal place. So again, this part here, I have rounded that slightly, but you'll notice I still went to 5 decimal places. Try not to round it to 1 or 2. You need to round it to at least 4 or 5 decimal places. So in summary of cosine and sine rule, to work out whether you're using sine or cosine rule, the important things are with sine rule, you need information on 2 sides and 2 angles. So what that means is a letter could be, like an unknown is information. So you need to have two sides and two angles, whereas with cosine rule, you actually need information on three sides and only one angle. And then once you've worked out which one it is, you label your triangle and you go from there.